This is about the structure, y-axis, x-axis, this z-axis. So there is a current flowing and uniform magnetic field is switched on. The magnetic dipole moment of loop, find the torque acting on the loop. Magnitude of current and side length given 1 meter. This will be 1 meter, 1 meter all. So what is the biggest problem? We don't have any loop here, no? So yesterday's I think we have discussed, no? So where all needed, we can bring equal and opposite current element and we can make it a loop. So where all the current elements are needed, one on y-axis, then one along z-axis, other along on y-axis, two parallel lines. So if I can bring one equal and opposite current element here, this will make one loop. Here also one equal and opposite current element. Here one equal and opposite current element. And here one. 1, 2, 3, 4. 4 equal and opposite current elements has to be introduced in a system. We'll give name to the edges. 1, 2, 3, 4, 5, 6, 7, 8. So I'll bring first one here. And construct the system. So there's a current I. So put that current should flow like this. So where all that red colors, they are introduced by us. So then calculate M bar. So how many things are there? So M bar, you calculate resultant M bar. Then check with the B bar. Okay, let me analyze. So this will be 1, 2, 6. What is the dipole momentum of 1, 2, 6? Will be along negative z axis, and that of 3, 7, 3, 7, 8, 4 will be along positive z axis. So that let me cancel out the terms 1, 2, 3, 4 plus M3784. This should be equal to 0. The dipole momentum of these two, like a sides, these two faces will be equal and opposite. Then similarly 5, 6, 7, 8. 5, 6, 7, 8. Then 1, 2, 3, 4. Equal and opposite. M1265. Oh, okay, fine. M1265, M3784. Okay, I'll make a correction. So numbers 5, 6, 7, 8. 1, 2, 3, 4. They are equal and opposite here. Now M2376 plus this will be M1485. M1485. Both will get added up. IL square, I cap, IL square, I cap. So 2I L square, I cap. There's a net dipole moment of the loop. This will be the net dipole momentum of the loop. Okay, directly we'll go for now the torque. Cross B I cap. So this will be 2i L square B j cap. I cross j will be k.
Sir,
So,
sir, you broke this down into 4 loops. The side 5, 8 and the side 1, 4, they are there only once, and you took that into 2 loops. We should make it only into 3 loops.
okay, you want to, there also one loop will come, no?
Yes, sir, but then we have to add an extra side along 5, 8 and 1, 4. Like there is only one side there which we are counting into 2 loops. For example, if we see side 6, 7, there are two. That is why we can take 2 there. But at
No,
5,
no,
8, there is only one wire.
not like that. This wire itself is there. No, here equal and opposite current element is brought. That's all. Nothing to do here. There. You don't bother that one. Don't try to add again one more if you want to add here. It's not like that here.
I'm not telling to add, sir. I'm telling we cannot, we need not even add 1 and 5. Without that, we'll get the loops. If we add 1 and 5, in fact, we'll get a different answer. Because 5, 8, there is only once, but we are considering that into 2 loops. Like the same current, we are taking it for 2 loops.
So this will be the structure. Huh? So here I think the current in fact the flow of current is like this. Huh? You can see now. This is structure here now. So here I'll bring one loop.
Sir, if you remove the equal and opposite elements you added across 1, 5 and 4, 8, even then you'll get 3 loops, and even then you can calculate and you'll get a different answer.
No. But you have to search for all things. No, it's like a the thing is B bar. So here what happened when you are constructing one loop here, equivalent opposite current elements. When you're constructing here, that one, how can you leave this?
Sir, then we need like we are taking the same part of the wire for 2 different loops.
Let it be, no problem.
It shouldn't be there like that.
No.
We are breaking it into loops, then how can one wire be common for 2 loops?
There you just brought equal and opposite current element. The idea is like this here. You're just bringing there. See, I didn't disturb anything in the system. I just introduced equal and opposite current method. So you mean to say, sir, how come 4 will be part of loop 1485 and 1423?
Yes, sir.
It can be, no? There is nothing like that. Effective system is what we are finding out here, no?
Sir, suppose you are actually physically adding those equal and opposite current elements in the actual circuit. Then with from basics, we can tell that at every junction there should be, we can apply KCL. Like for 6 and 7, when you added, you can apply KCL until support that, where you added the equal and opposite. But the same thing you do for 4 and 8, it won't
No,
support it.
yes, see, like it's for our convenient, we have brought it here. So there's nothing like a KCL, you should apply anything here. The main idea here is like, or else what you have to do, calculate the force on individual arm. If you get the torque, what we did like this, what we assumed is right, or else wrong, we have to change the method.
Sir, once can you, not now, but afterwards, can you do by that method and confirm, sir?
Yeah, sure, that one. Just go for this equal and opposite current elements to make a complete loop, then try to analyze here. Because along y-axis, there is no wire. Along y-axis, there is no wire. That one. Or else what you have to do is like, here two currents are there. So here you leave it. This one, calculate that one, calculate torque, how to, and assume one more diagram. I'll do one thing, I'll just, see, this is only, you can select what we are making some assumption to get the answer very easily. So what you have to do is like you have to go for, I'll just put separately here. So you remove this part. I think that's what you are suggesting it, no?
Yes, sir. Now if we write for this, we write the same expressions, we'll get different answer.
Now whether we are right or wrong, how to justify that, and also we should calculate force on individual arm. That one, the force on individual arm. Clear this. Then which particular thing will it obeys is what? That will be the final method. This is what we have made it's a method. Not something that one, it's a method. So this is the other possibility. Then you have to check out the torque. How much you'll get here?
BIL square.
BIL square K cap.
Now there's a difference in there. Now what you have to do is force acting on individual arm. With that weapon, we should make a search of a torque. This is K cap. Now about Z axis, we should search for a torque acting on individual arms. Then okay, we can justify because there's only method we have brought it. I'll just write it here. This is the first method. This will be second method. Which one is right or wrong? So how to justify? Books, the given answer, comparing with that, or else about Z-axis, we should calculate the torque. If that is which one is satisfied, then that method will be correct here.
Sir, in 1, 5, 4 and 8, we are considering the loop again, no sir. 5 and 8 and 1 and 4 are already considered in one of the loops, no sir. How can we consider it again, sir?
See, this is what equal and opposite current. First student is thinking like this, second student is thinking now.
Sir, but 5 and 8 and 1 and 4 are already included in other loops, sir. In that case, we can take 1, 2, 5, 6 as loop and 3, 4, 7, 8 as also one of